First Hop Redundancy Protocol. So we're going to talk about the purpose and the operation of First Hop Redundancy Protocol. And one of the examples of the protocols is HSRP. We're going to discuss it and demonstrate it also. You will see this at work. First Hop Redundancy Protocols. What is it? What is it going to help us achieve on the network? I've just explained it or summarize it. It's going to help us overcome default gateway limitation. What does that mean? Is this guy not contradicting himself? Nope. Nope. What do I mean by default gateway limitation? End devices are typically configured with a single default gateway IPv4 address. We all know that. If the default gateway router interface fails, LAN hosts lose outside LAN connectivity. This occurs even if a redundant router or layer 3 switch that could serve as a default gateway like this. So what are we trying to say here? I just drew something for you people here now. Let's say this PC1 is connected to this switch, and this router is connected to the service provider. On this PC1, it's going to have its IP address. We know that. It's going to have its subnet mask. It's going to have its default gateway, which is the IP address of the router here. If we bring in another router connected to the service provider and also connect to this switch, this router too will have an IP address. So if this router goes down and people need to go through the second router, how are we going to go and tell this PC about the default gateway? It means we have to go and change the default gateway manually, because the default gateway has changed from this place to this place, because this is the router that is now working now. And that is not going to make sense. So what the protocol does is to help us balance this equation, or to solve this problem. So we don't have to go to our devices and change default gateway address. And you will see how it is implemented. First hop redundancy protocols are mechanisms that provide alternate default gateway. Take note of that. In switch network, where two or more routers are connected to the same VLAN. So we can achieve alternate default gateway automatically without going to change anything manually. We can achieve that on our network. So how are we going to implement this now? We're coming there. So if we implement this, or we put this to work, these protocols to work, what we achieve is called a router redundancy. Meaning one router goes down, the other one picks up. And when that one comes back, the one that went down before will come up again. And that is called router redundancy. That is what this protocol will help us achieve also. So one way to prevent a single point of failure at the default gateway, watch out, is to implement a virtual router. What is a virtual router? You know, in networking, anytime we talk about virtual, you know that it's not physical. It's not physical. Take, for instance, when we did intervalent routing, you see that we used some interfaces. It's not physical. When we use the switch to do our intervalent routing, we use the SVI. These are not physical interfaces, but they can do the work of physical things. So in networking, or let me say in IT generally, some things that are not physical are real. They can work like physical stuff. So what is this virtual router? That is not physical and can still do the job of physical router. We're going to demystify it. To implement this type of router redundancy, please mute yourself. Somebody is distracting us there. Mr. Adekola, please mute yourself.
Yes, sir.
Mute yourself, please.
Okay.
Thank you. Okay, so to implement this type of router redundancy, multiple routers, take note please, multiple routers are configured to work together.
What? I'm not removing it on my leg or saying about the test and make sure it's follow. If you match it,
Maxwell, please mute yourself. Thank you. Who wrote to me and said it's Maxwell? Mr. Samuel, thanks. Probably you need to help me whenever people are distracting us. Just let me know the person that is distracting so that I can just call them. Okay, I go through. Thank you. I appreciate that. So now, to implement this type of router redundancy, now listen and listen attentively now. Multiple routers are configured to work together to present the illusion of a single router to the host on the LAN. So I can have 2 routers, I can have 3 routers, I can have 4 routers. They all are going to have their different IP addresses, but my computers will think it's only one router that is available. And we are going to use this protocol to make them work together as if they are just one router. By sharing an IP address and a MAC address, 2 or more routers can act as a single virtual router. We're going to see it. The IP version 4 address of the virtual router is configured as the default gateway for the workstation on the specific IPv4 segment. So when we make 2 or more routers to work together as one router, what they create is called a virtual router. And that virtual router gets an IP address. And that IP address is what will not tell the computer as their default gateway. So it doesn't matter any route, the router that is available that is alive, the computers don't need to know about different routers' IP addresses. They only need to know about the virtual router's IP address and seize it as their default gateway. I'm going to demonstrate that. Just follow me. When frames are sent from host devices to the default gateway, that is, somebody is trying to send something, the hosts use HARP, I've taught HARP in this class before, to resolve the MAC address that is associated with the IP version 4 address of the default gateway. The HARP resolution returns the MAC address of the virtual router because it is a virtual router that is working now. It has its own IP address, that is its own MAC address. And the good news is any of the routers on our network can answer to that hub and represent the virtual router. Frames that are sent to the MAC address of the virtual router can then be physically processed, take note again, by the currently active router within the virtual router group. Just be patient. I will show you now. A protocol is used to identify 2 or more routers as the devices that are responsible for processing frame that are sent to the MAC or IP address of a single virtual router. Host devices send traffic to the address of the virtual router. A physical router that forwards this traffic is transparent to the host devices. So what is all these things? What are these storage? Well, to be speaking. So let me explain some things to you here before I continue. Let me go to my blank. So I have a router here. I have another router here. This router is connected to ISP. Another router is connected to ISP. Let's call this one router A and call this one router B. And both of them are connected to my switch. And then this is my switch. And then I have a computer on the network, or plenty computers on the network. This router A and router B will be made to work together as if they are one router. And guess what will happen? They will create what we call a virtual router in between them. And that virtual router is also connected logically to the switch. This is just an illustration of what's happening spiritually now. Let's borrow that one. So this virtual router will have a MAC address. It will have an IP address. And that the IP address of this router is what we are going to give this computer as their default gateway. We give this computer also as default gateway. But guess what? Router A and router B will not be working simultaneously. One is going to be active, and the other one is going to be on standby. So any router that is active is one responding to the IP address, the virtual router's IP address, and the MAC address of the virtual router. If this one goes down, this one will come up, and this one will begin to respond to that IP address. And you can have more than two. You can have another router to connect to this service provider. You can have another connect to another service provider. I think you can have a maximum of 8. So we're going to use technology to bundle these two routers together, not like in Ether channel, please, as in to make them to work together so that they understand, okay, you stay, let me be active. Then when I'm done, you come up. And then the computers on the network don't even know that there are two different routers on the network. Let me tell you a few more things, and then we go to lab. Let's lab. Let's read this. Let's take care of this place, and then we'll lab. A redundancy protocol, which is our First Hop Redundancy Protocols, it's the same thing. It provides a mechanism for determining which router should take the active role in forwarding traffic. Both of them cannot work simultaneously. It also determines when the forwarding role must be taken over by a standby. So we're going to have active router and we're going to have standby router. The transition from one forwarding router to the another is transparent to the end devices. What does that mean? The computers don't even know that routers have changed. Default gateway have changed. We have moved from router A to router B. They don't know because they have just one default gateway IP address. And the ability of a network to dynamically recover from failure of a device acting as default gateway is known as First Hop redundancy, meaning things will just continue normal. And people won't even know that one router went down and another router has taken over. Let's lab this and see. This particular lab is the same lab I'm going to send to you guys to do. So I decided to use it to practice just the basic one. I need you to follow me carefully now. Look at what we got. I have LAN here. I have LAN 2. This computer here can pass through router 1, router 2 to go to the internet. This one here can pass through router 3 and then router 2 to go to the internet, to go and reach this server. But why can't computer here pass through router 3? Or why can't computer B pass through router 1? Why? Let's check something here. Let's check their default gateway. On router, on PC here, rather. We go to PC here, we say IP config. IP config. Look at the default gateway of PCA. 192.168.1.1, which is the IP address on this router here. We can confirm that also. If we go to this router here now, we can check the IP address of this router. Show IP interface brief. Look at the IP address on it. 192 is on gigabit 00. Look at the IP address. So PCA is using router 1 as its gateway to go out. What about PCB? IP config. PCB is using router 3 as its gateway. Let's confirm the IP address of router 3. See the IP address here. So they are stuck. Each of them are stuck to just one router as their default gateway, but we don't want that. So if we don't want that, what can we do? We can implement what we call HSRP. HSRP is one of the router or First Hop Redundancy Protocol. There are 3 types. We're going to come to the types later. Or let me just say we can implement First Hop Redundancy Protocol. We pick one of them. There are different types. Let me just show you those stuff. I'm coming back to my lab immediately. Look at them here. I have HSRP, I have VRRP, I have Gateway Load Balancing Protocol. These are all kinds of First Hop Redundancy Protocol. But the one that is in this curriculum is HSRP, Hot Standby Router Protocol. Hot Standby Router Protocol. That is the one that we want to implement right now. It's one of First Hop Redundancy Protocol. One of. The others are still there, but they are not covered in this curriculum. So back to our topology here. What do we want to do here? We want a situation whereby router 1 and router 3 will work together and present the illusion that they are both of them are one router, or they will create a virtual router between themselves. And we will now go and give our default gateway that virtual router's IP address. We give it as default gateway address to our computers. What's our objective in this lab? We want to be able to ping this web server here. This web server here. I want to be able to ping this web server. This is assumed to be on the internet. That's why you're seeing internet here. If I ping from here right now, you see that my ping will pass through this place. If I ping from here, it will pass through this place. But by the time we create virtual router in between, it is only the router that is working that will respond to that ping. So before we implement, let's try to ping and see. Let's try to implement and see. Let me write the IP address how. So if I go to computer here right now and say ping 209.165.200.256. Huh? What does that mean? Let me ping gateway first. Where did I get my 256? What kind of IP address is that? 226. Ali, you did not rescue me.
He had already said that, so.
I was wondering now, because you can't have 256 now. We see that this computer can ping that server, but we need to find out which part did he pass through to ping that server. We do trace RT. I don't think I've ever talked about trace RT in this class. Trace RT is to show the paths you pass through to get to destination. If you're on a router, you say trace route. If you're on the composer from command line, you say trace RT. So we say trace RT 209.165.200.226. You will see that this computer is passing through 192.168.1.1, and that is our router 1. What about the computer 2? Let's see. Can he also ping 209.165.200.226? See that he can ping. So let's now trace route and see. Where are you passing through? There are two routers. Where do you pass through to go to that destination? 209.165.200.226. You see that this guy is passing through this place, 192.168.1.3. So they are both stuck to just one router, and we don't want that. So what can we do? We can implement our HSRP. How do you implement HSRP? We pick a number, or let me say we pick an IP address that the two routers can answer to. Like we have .1 on this router, we have .3 on the other router. We can use .2 for our virtual IP address. Now, what I mean by that is this. Let me show you something here. My logical router or virtual router will need an IP address, and that IP address must come from this network. You know, all this is a LAN. They are using 192.168. I think 1. Let me check. This guy is on 1.0. That should be the 1.0 network. .1.0/24. This router has been given .1. This one has been given .3. This is our logical router. This is our imaginary router. That's another word. We can decide to give it .2. And if we give this our imaginary router .2, this router can answer to that .2. This router can answer to that .2. And we have to go to our computers and tell them about this imaginary IP address. R2 is a different network entirely. You see, this link is a different network. Between this router 1 and R2, you can't have the IP address. Ali, do you understand? The link between two routers is a network. We're going to come to that on Wednesday. You know, you guys are used to LAN. So how do we do that? Very simple command. Let's do it. I'll go to my R1 router, enter that interface where I have the IP address, interface G0/1. Watch out. Now I want to configure HSRP. How do I configure HSRP? I will say standby IP. You know, I'm always trying to check the command. Sometimes I miss one or two things. Standby IP is supposed to have a number first. Standby 10. I picked 10. Why did I pick the 10? You can pick from this range, sorry. Standby, you can say standby 1. So you can say standby 2. You can say standby 3. You can say standby 4. You can say as any number within that range. But any number you pick on router 1 must also be used on router 2. That is called a group number. If I use it on this router, and I go and use on another router, the same number, group number, and the same virtual IP address or IP for virtual router, we understand that, oh, this protocol has been activated. So we can say standby IP 192.168.1.2. If I hit enter right now, that protocol is activated on router 1. I'll go and do exactly the same thing on router 2 with the same IP address. They will now work together. They will belong to group number 10, and they will have virtual IP address of 192.168.1.2. So I'll hit enter here. I'll go to the other router interface also and do the same thing. That is G0/0. And guess what? Basic. I'm done. What do you mean by you are done? We're done. That is the first step. Do you mean that this thing can work or not? It's going to work. So what we need to first of all find out is this. The moment, that's the command, Ali. The command is standby. That doesn't mean that they will go on standby. The command is standby. Exactly. Yeah. So the moment we do it on router 1, we put the same command on router 3, something is going to happen between the two of them. They are going to talk together. They are going to have a discussion. Who is going to be on active? Who is going to be on standby? So those are the things we are going to discuss theoretically as we could proceed. But let's find out now. Somebody is now the active. Another person is on standby. Who's active? Who's standby? I don't know. Let's find out. Router 1. What are you? I will go to privilege mode and say show standby. Yeah, you can use that as long as it's available, as long as it's within that network. Mr. Samuel, any number can be used as long as it's within that LAN. Is it clear? Show standby brief. Show standby brief. What do I want to find out? I want to find out who is my, don't let me do brief yet. Let me just use show standby first. Watch out what I got here. On this interface, the group number is 10. The state of this router is active. So my router 1 is the active router now. Virtual IP address, look at it here. Active virtual MAC address, look at what it generated. Now this is another thing I need you to see there. Active router is local. I am the router. I am the active router. Now I'm the one in charge right now. And the standby is the other router on the other side. The priority is 100. That's default. We're going to talk about that later. So what does this mean? We have to go to our computers and change their default gateway addresses to the one we are going to be using. So I'm going to change this one to 192.168.1.2 because that is the IP address of our virtual router. Virtual router. I'll go to the other one too. Change the gateway to .2. That's the IP address of our virtual router. So we are going to repeat the same thing we did earlier. Let's go to computer 1. We want to trace routes to go to that destination. That destination we went to earlier. Let's see where it will pass through. This guy is passing through 192.168.1.1. Why? Because that is the active router. We've achieved that. That's what it was using before. But let's go and check the other guy. I'm coming to answer your questions, please. Just follow me. This guy was passing through 1.3 before. Let's see where it's passing through right now. It's passing through 192.168.1.1. So both of them are passing through 192.168.1.1. Why is it? Okay, I think I understand. I'm coming. Let me check something here. Okay, I understand. So who is the one with who has that IP address of 192.168.1.1? Our router 1. That is his physical IP address. But what if that router 1 goes down? Let's shut down that interface of router 1 and see what happens. Interface G0/1. Let's shut it and go back and ping. This guy now, you were passing through 192.168.1.1. That is router 1's IP address, physical IP address now. If we try it again right now, let's see what's going to happen to the guy. Because that 1.1, that 192.168.1.1 is down. What did you guys see? The guy has changed his paths. He's passing through who now? He's passing through router 3. This other guy, what happened to this other guy also? This one too is also passing through router 3. Why are they both passing through router 3? Because router 1 is down. So what happens to router 3? Router 3 has changed states to active. Show standby. This guy is now saying, I am the active. Look at the standby. There's no standby. I don't know any standby anyway. I just know myself. So when you create this virtual router, you don't need to do anything. You create the virtual router IP address. You don't need to do anything on the computers on your network apart from telling them about the virtual routers, the IP address. Once you inform them, if there are 4 routers that join together to work together, one goes down, the second one will take over. The second one goes down, the third one will take over. The third one goes down, the fourth one will take over. So you are not going to have to crack your brain on changing default gateway between your routers because of the illusion you've created and you've presented to your computer about the virtual IP address. It's as simple as that. And guess what? How many commands did we issue? Just one command, and we'll set it up. Let me bring that interface up again. Just one command. What's that command that we issue? We just went to the interface and issue this command on both routers that are connected to the LAN. And that activated HSRP. There are other options, other commands we're going to activate. We're going to learn about them. But before we go to those ones, let's be sure that we're on the same page with this one. Yeah, somebody asked me a question now. Let me try to answer the question. Mr. Maxwell, how will the administrator know that the router 1 is done? Network management is a topic in this class. That's next class, next in CCNA3. That's a good question, very good question. Because you are the owner of the, or let me say you are in charge of the network. You should know what is going on your network. And one of the ways you get to know what's going on is by logging things on your network, syslog. And we are going to come to that too. Are we good? Do we understand this concept? Okay, somebody is at least saying, if both routers were not connected directly with physical media, then this protocol will not be activated. You know, these ones are connected through switch. It's a LAN stuff. It's about a local area network. Do you understand, Ali? So the routers need to be together. They need to be on the same LAN, on the same network. The interfaces have to be on the same network, connected by a switch before this protocol can work. Because we are referring to redundancy protocol or a redundant router for that local area network. So it's not about wide area network. Yes, Mr. Samuel, can they work using VLAN? Yes, of course. They work with VLAN. That's why you have more work to do. So you have different virtual IP address for different VLAN. VLAN 10, VLAN 20, VLAN 30, VLAN 40, all those default gateways we use on our router, they will now be the virtual IP addresses. It's I don't want to say complicated. It's not complicated. You just need to understand the concept. Yeah, they work on VLAN. See, anything that works on physical LAN, you can make it work on VLAN. Anything. DHCP, HSRP, anything. Yeah, keep the question coming, please. Any other question? Okay. Do you people understand this? Can we proceed? Give me, yeah. Oh yeah, I want to reply from other people. Only 3 or 4 people are responded. Eniola, are you flowing with this? Okay, good. Mrs. Davis. So this is just how we activate backup at layer 3, redundancy at layer 3. We create the illusion of a virtual router. You see our topology again. What did we do? Very simple. We just created a logical router, gave it an IP address, and we went and told our computers about that IP address. So any active router will answer to that IP address, even though it has its own IP address. And if that router goes down, the other one will pick up and still answer to that IP address. If this one comes back, the other one, if this one comes back, the other one can go back on standby, depending on what you have activated on your network. And so let's see some other conditions. We just took one step now, but we have to go beyond that. Let's see. So now, if I read this statement again, it will make sense to you. One way to prevent a single point of failure at the default gateway is to implement a virtual router. We just did that now. To implement this type of router redundancy, multiple routers are configured to work together to present the illusion of a single router to the host on the LAN. And by sharing an IP address and a MAC address, two or more routers can act as a single virtual router. So don't ever forget that. And that is what we've just implemented now. So how will router B or router 3 know that router 1 is done? How? Because I shut down the interface and then router 3 took over. And I brought the interface back, router 1 came back up. So these are steps for router failover. Failover is you are moving to the next device that is available. When the active router fails, the redundancy protocol transitions the standby router to the new active router role. You can see in this place now. This link was shut down. And what happened? This guy took over. Of course, this is our virtual router in between. So the same service provider. These are the steps that takes place when the active router fails. Number one, the standby router stops sending hello messages from the forwarding router. What is hello messages? Hello messages is just a message to keep track of themselves. It's like me telling you guys, hi, are you guys still there? Hi, are you guys still there? Hi, are you guys still there? And you respond back to me. So when this standby router does not hear anything from the active router again, it has a timer. I think we're going to see the time. He knows that there's something wrong with this router. We have agreed to talk every 5 minutes, but I've not heard from the guy after for the past 10 minutes, 10 seconds now or thereabout. Then it will not take over. 2, the standby router assumed the role of the forwarding router. That is to start forwarding devices traffic now. Because the new forwarding router assumed both IPv4 and MAC address of the virtual router, the host, that's the computers now, devices, sees no disruption in the service. They don't even know that something happened. So these are different types of First Hop Redundancy Protocol. One is HSRP, which is for IPv4, HSRP for IPv6. We have VRRP and VRRP3. And by the way, I forgot to mention that this belongs to Cisco. It's Cisco proprietary. This also belongs to Cisco. But if you are working on any other router that doesn't belong to Cisco, this is the one you are going to activate. And this one is old school. It's no longer in use. So they are talking about the protocol itself now, which is the HSRP. I've demonstrated that, but let's go into the details of this HSRP. Cisco provides HSRP and HSRP for IPv6 as a way to avoid losing outside network access if your default router fails. We've explained that. And this protocol is Cisco proprietary. It is designed to allow for transparent failover of a First Hop IP device. No, meaning the computers don't even know something else has happened. HSRP ensures high network availability by providing First Hop routing redundancy for IP hosts on the network configured with IP-default gateway address. HSRP is used as a group of routers. Take note, we've discussed that and we've them implemented it. It's used as a group of routers for selecting an active device and standby device. In a group of device interface, the active device is the device that is used for routing packet. The standby device is the device that takes over when the active device fails or when the preset conditions are met. And those are some of the things we are going to set now. The function of HSRP standby router is to monitor the operational status of the HSRP group and quickly assume packet forwarding responsibility if the active router fails. So I've explained this. The active fails, the standby takes over. The active fails, the standby takes over. But there are some things we saw from the output of show standby that I didn't discuss. We saw priority. We saw preempt. Let me show you. Show standby. Router 1 was active before, guys. It's back, but now it's on standby. His priority is 100. Sometimes you don't want this kind of scenario. Let me explain to you why. You may want a situation, or you have a situation whereby you want this router to always be the active router as long as it's alive. But if the guy is active now, and the other one is on standby, when this one dies, what happens? This one becomes active. Now, when this router 1 now, that is router 1 now, when it comes back, you don't want it to be on standby. You want it to be active. But as long as this guy has taken over as active, he's not going to hand over to this guy. This guy is going to sit down as standby. Let me explain myself again. This is active for now. This is on standby. This is active. This is standby. This goes down. This guy becomes active. When this guy comes up, he goes on standby. But that may not be what you want. You may want this guy to always be on active because probably it's a powerful router. Or maybe this link here, you have more bandwidth, maybe 1 gig. Maybe here you have 100 Mbps or something. You probably want a router to always be active. As long as you want a router to be active, you need to set some condition. And the condition you are going to set will say, okay, if as long as this router is alive, it must be the precedent. It must be the active. If he goes down, fine. Or you can help the router out. But once he comes back, hand over to the guy. But as it is right now, this our router, when it came back, it assumed the status of standby, and that may not be what we want. So what are the conditions we can set? Look at the conditions here. HSRP priority and preemption. The role of the active and standby routers is determined during the HSRP election process. Once we have chosen who becomes the active router and who becomes the standby during election, that is the end. By default, the router with the numeric highest IPv4 address is selected as the active router. Who is going to win the election? Any router that has the higher IP address is going to win the election. But sometimes it doesn't work that way. It's the router that comes us first that wins that election. However, it is always better to control how your network will operate under normal conditions rather than leaving it to chance. You should be able to decide the router you want to be the active router. And that is when we cannot begin to do some things. One of the things we can do first is HSRP priority. It can be used to determine the active router. The default is 100. I can change for a particular router. I can change on a particular router to 150. So what happens? See it here. The router with the highest HSRP priority will become the active router. So IP addresses will not be considered this time around. The highest IP address is the priority that will be considered. And of course, the default is 100. If the priorities are equal, the router with the highest, that is with the numerical highest IPv4 is selected as the active router. So to configure the router to be the active router, we are going to use the standby priority command. So let's implement this here. Let's assume we want this our router 1 to always be the active router. And now the guy is on standby. We're going to say We don't want this. We'll go to that interface. Interface G0/1. And we're going to say, what's that command? Standby priority. Look at the range here. By default, this guy has a priority of 100. But now I want to change the priority. So I'll say standby priority. Let's make it 120. So let's see if it has a higher priority number now. Show standby. Do show standby. You see, what is it? No. That's not the right place to put this command. I think, let me yank it off and go back. Let's go to the first command we're using before, which is standby, this place. I think it should be here. Let me look for it. It's from here. Standby 10, our group number. Don't forget that, sorry. Priority, then 120. Standby 10, priority. Look at all the commands we have here. This is the one I'm using right now. So I need to confirm if it take it. That's taking this. Now you see, it's telling me that the priority of this router is 120. But guess what? The state is still on standby. So why didn't it just move to active? The election has taken place. The other guy is already on active. And the other guy is 100. Let's go to the router 3. The priority number for that router is 3. I said 300. The router 3, the priority number is 100. You can see it in this place. And this guy is active. So how can we take over from this guy? Router 1 is alive. And we want router 1 to always be the president, the active router, as long as it's alive. There's one more condition. One more thing we can do. And that is called preempt. So it is not enough for a router to have a higher priority number. If you want that router to always be the president as long as it's alive, you have to say something called preempt. What is preempt? What will preempt command do? The preempt command will trigger the election process once the router comes back. Let's see it here. By default, after a router becomes the active router, it will remain the active router even if another router comes online with a higher HSRP priority. Watch out now. To force a new HSRP election process to take place when a higher priority router comes online, preemption must be enabled using the standby preempt interface command. Preemption is the ability of an HSRP router to trigger the election process. So this router one will say, I am back online. Let's do that election again. The one that you people did that you made the router 2 or 3 to take over. It's no longer effective. It's nullified. So with preempt command, they will do the election again. And that router with a higher priority number can now become what they call the active router. So with preemption enable, a router that comes online with higher HSRP priority will assume the role of active router. Preemption only allow a router to become active router if it has a higher priority. A router enabled for preemption, watch out, with equal priority, but the higher IP version 4 address will not preempt as active router. What does that mean? If this guy has priority number of 100, priority number of 100, and we book preempt on this router, even if when it died, the other one will take over. When it comes back, it's not going to become the active. Why? Preempt only works with higher priority number. And let's see it at work here. This our router is still on standby. Router 1 is still on standby. But we want to change the story right now. What do? Can change, say standby, preempt. The moment I hit enter right now, this router 1 will signal we need to have another election. You're going to see. And what has happened? Did you see what happened? The guy has become the president. How come he became the president? It has higher priority number, and we activated preempt. If I shut down that interface again now, that interface we shut down before, the other guy will take over. But once this guy comes back, once this guy comes back, he will take over from that router. You see? See this guy? This guy is now active because the first router is done. The active router is done. So it doesn't care about the active router again. But the moment I bring up the active router back, the guy will say, we need to do this selection again. And he's going to take over. You watch out now. It's going through different process stages. And of course, it's going to become the president again. You see, going through listing, then to speak. I'm going to explain that one later. And then he's going to become the president. So if this timer is too long for you, you can change the timer. And here we have. This my router one has now become the president of the network. So sometimes you want to achieve this if you have a strong router, you have more speed on that link to connect to the service, whether maybe 10 gig, maybe it's just 1 gig, and you just want this one to just be a backup link. So you are not paying for too much bandwidth on that second link. So you may want to activate preempt on this router, and then make sure you increase the priority number so that anytime this guy comes up, he becomes the president and connect to the network. Any question on this, please? Okay, Ali, thank you. Are we cool with this concept? Okay, thank you. Please let me be sure you guys are flowing, you understand this. Okay, so the technology is very easy to implement, very easy and straightforward. And it's this same lab that you're going to do. I will send it to you people after the class. And just that you are going to follow the guide. Okay, good. So now, we're talking about priority. Any router with higher priority becomes the president. Preempt should be activated. Note, with preemption disabled, we don't have preempt. The router that boots off first will become the active router. That's what happened the first time when we started those routers. If there are no other routers online during the election process, so if I am the only router, I will just select myself. The moment you activate that HSRP on router 1, it will just select itself as active router. Take note of that. Now, when you activate, now you see that it took some time before that my router became active. Why did it take some time? The HSRP, there are different HSRP states. Different HSRP states. The first stage is the initial, when an interface just became available. The second stage is learn. The router has not determined the virtual IP address and has not seen hello message from the active router. So what does the router do in this place? In this state, the router waits to hear from the active router. The next stage the router goes through is the router is listing state. The router knows the virtual IP address, but the router is neither the active router nor the standby router. It's listening for hello messages from other routers. And then we have a speak state. The router sends periodic hello messages and actively participates in the election of the active and standby router. And of course, we can have a standby state. The router is a candidate to become the next active router and also send periodic hello messages. So these are different states. If you're on a live router, you can use debug command to see how this works immediately. But sometimes Packet Tracer doesn't support some of these debug command. Let me see if I can issue debug with HSRP. Debug what? Ah, beautiful. Debug standby packets. That should work for me. So let me do something. Let me shut down that interface again. So things that have to do with now I've shut down that interface. So I'm going to bring it up again. So let's say no short. So you're going to see as the router is going through those different stages with the output of debug command. Did I bring it out? Okay. I think it's coming. Show RP interface brief. I brought it back. Show standby. Okay, it's coming. It's coming. You see? So you see it's going to keep on showing us the messages coming in as far as HSRP is concerned. I'm supposed to see, I'm looking for all those states. It's supposed to show us those states as it's going from listening to learn, from standby and all of those things. But it didn't show me this, what I'm looking for. It has gone to active already. Show standby. It has gone to active. It didn't show me that. But on a live router, you'll be able to pinpoint a particular debug command that will show you troubleshoots. Okay, I've turned on the debugging. So debug command is a command that enables you to see the live output of some protocols, but you must be able to filter. That's the right word I'm looking for. Filter what you want out. So what I wanted to show you guys is the different state. I wanted to show different state of the HSRP as the router goes from the listening, the initial to learn to listen to speak and then to active or to standby. So these are different stages that your router goes through, and you need to be aware of that. So the last part of this is the active and standby HSRP router sends hello packets to the HSRP group multicast address every 3 seconds by default. If this is not good enough for you, you can reduce it. The standby router will become active if it does not receive a hello message from the active router after 10 seconds. If this is too long for you, you can reduce it. You can lower these timer settings to speed up the failover or preemption. However, to avoid increased CPU usage and unnecessary standby changes, do not set the hello timer below 1 second or the old timer below 4 seconds. I don't know why they said that because in CCIE we were even told to use milliseconds. But these are recommendations from Cisco for you. So we can tweak this thing if we understand the protocol. But if you don't, just allow it to work at the default. So that is the basic things we need to learn. There are other stuffs we need to learn about, or you are going to learn about HSRP in the future, because take note, I only make reference to what if this link goes down or this link goes down. What if the two of them are working and this link goes down and this is our active router? What is going to happen? That is beyond the scope of this class. Or what if we have two different service providers connected? This is another internet connection and it can link this place. And we are passing through ISP-A. And ISP-A is down. This link is up, this link is up. So we can also configure our HSRP to say if you can't pass through ISP-A again, fall over to ISP-B. This is no longer about router now. But this is beyond the scope of this class. Any question? So that is HSRP for us there. Okay. Are we good with this? So I'm going to send the lab immediately. Try to do the lab because it is in doing the lab that you are sure you know the thing. It is very easy to listen in the class and think, I can flow, I understand everything. By the time you want to do the lab, that's when you know that, it's like I still have a problem with this thing. So the essence of the lab is to cement the knowledge for you. All right. So we don't have any question.